Good morning, class. Today we'll talk about modeling with linear functions, and we can use linear functions to model real-life situations, to solve, to represent real-life scenarios or real-life situations, as you're going to see further in the video. We'll start off with a small example that is requiring us to find the area that's bounded by the x-axis. It's a triangle, and its area is bounded by the x-axis, this line, and another line perpendicular to the f of x that we've been given. So I'm going to try to sketch this out. This is an approach you can take. You sketch it out. It doesn't need to be accurate. This is my x-axis. The line f of x is equal to 12 minus a third of x will have a y-intercept of 12, so that's going to be 12. Its slope is negative 1 over 3. I hope you see that. Negative 1 over 3. So I know negative 1 over 3 is rise is 1, run is 3, negative, or right, drop 1, and then run 3. So the next point is going to be somewhere here. Next point will be somewhere here. So it's going to be a line that kind of generally looks like that. Again, it's just a sketch. Okay, so that line, and then another line that is perpendicular to f of x. So since f of x is 12 minus 1/3 of x, another line that's perpendicular to f of x, remember if lines are perpendicular, then the product of their slopes is negative 1. So if I'm looking for another line that's perpendicular to this one, since m1 is negative 1/3, I hope you can see that the slope of that line will have to be 3, because when you multiply 3 by negative 1/3, you get negative 1. And that line is passing through the origin, so I know for sure that that line is going to look something like this, right? Y is equal to, passing through the origin, y is equal to 3x. Now, I have my triangle, and all I need to do is find the area under this triangle. In order for me to find that area, I need to know this base, and I also need to know this height, right? That height. So, to get the base, since I know the base is the distance from this point to this point, I'm simply going to find, and I know this point is the origin, so its coordinate is 0, 0. I'm going to need to find the point where this line, f of x, cuts the x-axis. Since f of x is 12 minus 1/3 of x, the point where it cuts the x-axis, I hope you remember from yesterday, is the point where the output is 0. So solving for this, I end up with 1/3 of x is equal to 12. Let me write that out. 1/3 of x is equal to 12, and when I solve for x, I end up with x is 36. So that tells me that this x value here is 36 when the output value is 0. The other point I need to find is this point of intersection of the two functions. So that point, I know that f of x1 is equal to f of x2, where f of x2 is a perpendicular line. Now, f of x1 is 12 minus 1/3 of x, f of x2 is 3x. I know that at that point, they should be equal because they are intersecting. I'm going to solve this equation for x to find out what the x value of that point is. Then after doing that, I'll substitute the x value in any of the equations to find the y value. When I solve for x, I hope you can see this is 12 is equal to 3x plus 1/3 of x. Simplifying that, I end up with 9 plus x, or basically 10x out of 3 is equal to 12. And end up with 36 is equal to 10x, and therefore x is equal to 3.6. So the x value of this point is 3.6. Since one of the equations that leads to the intersection is y is equal to 3x, if I want to find the y value at this point, I'll just substitute 3.6 in this equation. So y is equal to 3.6, that is 3 times 3.6, I think that is 7.2. Let me confirm. No, it's not 7.2. 3.6 times 3, 10.8, sorry. 10.8. Alright, so I know the base of the triangle. I know the base is going to be 36 because this x distance from this point to that point is 36. The height of the triangle is going to be the y distance from this point to that point. That's also 10.8. I can use those two values to find the area of the triangle. Area is equal to half times base times height. Half times 36 times 10.8. And I end up with some answer which is going to be the area of that region. So I have used linear functions to try and find the area of that triangle. Alright, this is what a graphic approach would look like. I mean, if you graphed it, this is what it would look like. Desmos would be able to tell you what the point of intersection is, but you can also do it without using Desmos or without using the graphing calculator, and that's the approach we saw earlier. This is what I was doing. Find the point of intersection. Find this point by substituting for the output value, and first find this point of intersection by making both functions equal to each other. So yeah, if you follow through, this is what I did on the previous page. Hope it makes sense. Alright, another one, we're trying to find the area of a parallelogram bounded by the x-axis. This is the x-axis again. The line g of x is equal to 2. This is the line g of x is equal to 2. This is the x-axis. The line f of x is equal to 3x. That line will look something like that. And the line parallel to f of x. So I need a line that's parallel to this one. And remember, if it's parallel, then the slopes are equal. So the slope of this line is also going to be 3 because the slope of f of x is 3. And that line is passing through the point, by the way, this is the origin. It's just bad drawing. That line that's parallel is passing through the point x is 6, y is 1. So that line, I know it's also going to look something like that, and it's going to have a slope of 3. I can find its equation because I know its slope. I can find its equation. Y minus y1 is equal to m into x minus x1. So y minus y1 is this value, 1, equals m, which is 3, into x minus x1, which is 6. So its equation is going to be y is equal to 3x minus, would have been 18, but then I add the 1 from this side, 3x minus 17. If I add 1, it becomes positive, so it's minus 17. I know that that's the equation of this line. 3 of x minus 17. It makes sense because I know that this line will intersect with this y-axis at some value that's negative 17. Alright, so I'm trying to find the area of this parallelogram. I know that the area of a parallelogram is equal to base times height. So that means I need to know this base, and I also need to know this height. Right? Alright, the base is I'm going to find the base by finding the x-intercept of this equation. The x-intercept of that equation is the value where the output value is 0. So if y is equal to 3x minus 17, set output equal to 0, then I'm going to find the x-intercept as 17 out of 3. Right? So I know this point here is 17 out of 3, y is 0. What else do I need to find? I need to find this point here of intersection of the two functions. I need to find where these two functions intersect, because the y value of that point will give me the height of the parallelogram. So in order to find that point of intersection, I'm going to set the functions equal to each other. 3 of x 3 of x is equal to this function g of x, and remember g of x was 2, so 3 of x is equal to 2. I solve for x and I get x is equal to 2/3. When x is 2/3, remember I'm trying to find the y value of this point actually I didn't need to go through all of this because this function is already telling us that y is 2 constant at this, across this line. The y value is 2 constantly. So this height is immediately going to be 2. So this one turns out to be easier than I was intending to show you. So the area is just going to be base times height. The base is 17 tags, and the height is 2, which gives you your value of the area. All right, so this is what it looks like when you graph it out. This is the point that we solved for using the approach I did in the previous section. So this is basically how you work it out. I mean, a more aesthetic looking way. If you sketched it properly, this is what it would look like. Let's look at another example of modeling. A town population has been increased at a constant rate. In 2010, the population was 46020. 46020. And in 2012, the population is 52070. So if this trend continues, what do you think the population is going to be in 2016? Well, what do we see? If I'm looking at this as time, then I hope you can see, if I call 2010 my initial time, or my starting time, which is 0, then the population is going to be 46020. After 2 years, so this is my time in years, after 2 years, the population is 52070. So if this trend continues, predict the population in 2016. 2016 is going to be after 6 years. That is 2016. So what is the population in 2016? Now, hopefully, I hope you can see that I've been given 2 data points. One data point is 0 for x value is 0, y value is 46020. Another data point is when the input value is 2, or when the time value is 2, the output is 52070. So I can use these 2 points to find a slope for this function, or a slope for this relation. The slope is going to be change in y divided by change in x, which is 52070 minus 46020 divided by 2 minus 0. The slope is going to give me an answer of, let's see, 52070 minus 46020. 6050. Divide that by 2, 3025. Please check my math, see if I got this right. So the slope is 3025, and I hope you can see that people, like population increase per year. That's how many people are added on this population per year. So if that's the slope, I can use the point slope form to find a relation, to find the equation of this relation. If I use point slope form, y minus y1 is equal to m x minus x1. So y minus y1, I'm going to use this point. That's 46020 equals m into x. X is x minus initial x is 0. So I end up seeing that, sorry, I got a slope. I have a slope value. Slope value is 30, this one right here, 3025 into x minus 0. So my equation is y is equal to 3025x plus 46020. That's my equation. As they're asking me to predict the population in 2016, 2016 is after 6 years. So I'm just going to substitute for the input value as 6 in this equation of the function. So I have y is equal to 3025 times 6 plus 46020, and that will give me the population of this town in 2016. Hope that makes sense. Alright, so again, identify the year in which the population will reach 75,000. So this is the equation we got from the previous screen. That was our equation. Identify the year in which the population will reach 75,000. So the population is the output. I'm just going to substitute for the output value in this equation. 75,000 is equal to 3025t plus 46020, and solve for the value of t. Solve for the value of t. So I'll end up with 3025t is equal to what you get after you subtract, then substitute and solve for the value of t. The weight of a newborn baby is 7.5 pounds. The baby gained half a pound. Now, newborn, that's initial when time is 0, like time is 0, newborn baby is 7.5 pounds. That's the starting weight, because the baby can't come out of the womb at 0 pounds. The baby gained 1/2 pound. I hope you can see that this is a rate of increase, 1/2 pound a month for its first year. Find the linear function that models the baby's weight as a function of the age in months. So the weight of the baby as a function of the time, which is the month, is going to be the initial value, which is 7.5, plus the rate of change, 1/2 times t, where t represents the number of months. And I hope you can see that this looks very similar to y is equal to mx plus b, where b is the starting point, and m is the slope, and x is the input value, or in this case, the variable. Alright, so we have our function, w is equal to 0.5, t plus 7.5, which really is the same thing as this, just rearranged. Find a reasonable domain and range for the function. Now, I'm going to graph this so you can see it better. If I graph this, its starting point is somewhere at 7.5, and then its slope is 1/2. So rise 1, and 2, rise 1, and 2, rise 1, and 2, 2, 2, 2, like that. So that's what the function looks like. Now, ask yourself, is this function going to continue indefinitely up to infinity, and what would that mean? Because if I graphed it, the output axis will represent the weight, and the input axis will represent the time. First of all, this axis cannot go up to infinity because no one lives up to infinity. But also secondly, this rate of change of the weight is not going to be true for this baby forever. The baby is not going to gain 0.5 pounds every month beyond the first year even. I don't even know if it happens beyond 6 months, for example. So the reasonable domain for this function is only going to happen at least up to 1 year, right? Up to 12 months. That's what the reasonable range is going to be, from 0 months up to, the domain. The reasonable domain, x value domain, is going to be from 0 up to 12 months. And the reasonable range will be the value, the output value that corresponds to 12 months. So the reasonable domain for this function is going to be from 0 to 12 months, and the range will not be from 0, because this baby does not start off with a weight of 0. The baby starts off with a weight of 7.5 up to a weight when up to the weight at 12 months. So I need to figure out what the weight at 12 months is by substituting 12 here, and then that will be the upper limit of the reasonable range. I hope this makes sense. If you don't get it quite clearly, please send me a question. Alright, if the function is graphed, find and interpret the x and y intercepts. Alright, I graphed it earlier. If I graphed it, it starts here. Interpret x and y intercept. The y intercept is the weight of the baby at 0 months. Like when they come out of the womb, that's the y-intercept. And I hope you can see that this is the weight at 0 months. Now let's try to think about the x-intercept, this value here. This is going to be, this x-intercept, if we calculate it by setting the output value is equal to 0, t plus 7.5. I hope you can see that when I solve for t, it's going to be 7.5 divided by 0.5, which is 15, negative 15. So this x value is negative 15. The x-intercept is negative 15 months, because remember this axis represents time in months. Now, negative 15 months for this kind of function, what would that mean? What does it mean for the baby? Is it even possible that this baby has a weight? I mean, because thinking of the meaning of a graph, this is the point where the output value is 0, right? This will be the point where the baby has 0 weight, if we just looked at the graph and what it means. But in terms of practical sense, it doesn't make any practical sense for this baby to have a weight of 0 at negative 15 months. Their parents haven't even met probably at that age. So, or, yeah, they haven't. I don't know. Just, it doesn't make sense. This is not a meaningful, the x-intercept is not a meaningful item or quantity for this relation. That's what I'm trying to say. If the function is graphed, find and interpret the slope of the function. The slope of the function is still 0.5, and I hope you remember that that is the rate of growth per month. This is how many kilos or how many pounds this baby gains per month. When did the baby weigh 10.4 pounds? This is an output value of 10.4 pounds, and they're asking us to find the input value that leads to 10.4. That's going to happen if we substitute for the output value as 10.4 and solve that equation for the value of t. I hope you can do this. Subtract 7.5, subtract 7.5, and then divide by 0.5. What is the output when the input is 6.2? Again, substitute for the input as 6.2 and then solve that problem. Alright, so this is going to be a homework. If you have any questions, send me an email or a comment.